Excellent. Do you want me to kick off, Rob?
Yeah, I think that sounds good. Take it
All
away.
right, lovely. All right. So I need to get my screen sorted because we're going to do some live coding today. There's going to be sort of robots going on. It's going to take me a moment. Just bear with me. The other thing I would say is, Rob, perhaps you can help me with this as well.
There you go.
Is that better?
Yeah, we got you. We missed you from when you said there's something that you need to do.
Apologies. Hop-in has a little mute button that I don't remember pressing.
Sure does.
Maybe I pressed it. Is this better?
Yeah, much better.
Lovely. Okay, right, great. So what I was saying was, Rob, when I've got everything set up, I won't be able to see very well, right? So if there's sort of questions that you can that come up, if you could curate them, that would be amazing. Right, let's kick off. I just need to get everything up because this is going to be a very practical session. All right, so thank you all. First of all, so my name is Martin O'Hanlon. Now I work for the Raspberry Pi Foundation. Actually, at the Raspberry Pi Foundation, I look after our online learning courses. That's my job there. However, I've also been a contributor to open source software for a long time now, and I want to talk to you today about one of my projects. And it's a project called BlueDot. Now, BlueDot is a super simple way of controlling your Raspberry Pi projects wirelessly using Bluetooth. Now, I actually created the sort of first alpha for this. I was looking back at when I'd done releases. Was actually launched about 4 years ago. However, there have been some significant changes to BlueDot recently, which I wanted to share with you. So BlueDot has just gone through its second major version, so we're now on BlueDot 2, and it allows you, with some imagination, to create some really sophisticated controllers. All right, for example, such as things like a joypad. Yeah, or interestingly, any other kind of combination of buttons that you can think of. So that's what we're going to do today. Today, what we're going to do is we're going to have a look at BlueDot. We're going to have a look at how to use it wirelessly to control a robot, and then we're going to create a custom control. Actually, this joypad that you can see now. So it's going to be a very, very practical session with lots of coding activities, and hopefully technology won't fail me because we've got all sorts of stuff set up to go on. All right. But first of all, what I thought we should do is let's do a little bit about history. So BlueDot started with PiCademy. Now, PiCademy is Raspberry Pi's teacher training program. It is it's a highly practical piece of CPD, continuous professional development, and we make lots and lots and lots of things that spin around, lots of kind of robots. Interestingly, people kind of really like to create little buggies that move about. But one of the problems that we faced at PiCademy is wires are a pain, right? And controlling wireless devices wirelessly is hard, right? And I sort of recognized this as a problem. And my initial objective, sort of going back to 2017, was how can I create a wireless button that is as easy to use as a physical button? That was sort of like my objective and my sort of idea for BlueDot. So what is it? Okay, well, so BlueDot is a Python library. So you write a bit of Python code, normally on your Raspberry Pi computer. And then there's an Android app. There's a Python app as well, but most people use an Android app, which acts as the remote. So the remote is the Android app, and then you write a little bit of a little Python program, and that's how you create your wireless connection. All right, so I'm going to switch screens now. So hopefully what you should all be able to see now is my robot. This is the robot that I created based on a Raspberry Pi project. When I tested it, I need to put the batteries in to make the motors move. So this is my robot. You should also be able to see, hopefully, my mobile phone. Let's just get up the BlueDot app. I'm just going to make sure you can. Oh my God, it's reversed. Is it reversed for you guys? That's right. On my preview, it's reversed. No. Okay. Brilliant. Right. Lovely. So right, I'm seeing the preview, and it reverses the preview, so it doesn't look weird for me. That's fine. Yeah. So you should be able to see my robot. You should also be able to see some code. So what I'm going to do. Oh my goodness, seeing the reverse is really confusing. So I'm actually just going to get rid of that. So you should be able to see my code. You should be able to see my robot. And where's my notes gone? Oh, there we go. Right, lovely. So yeah, here's my robot. Sort of here is my program over that way, I think, right, which is running. That's actually running on VNC on this robot, right? this is the BlueDot Android app. So what we're going to do is we're going to run this program. And if we look at it, what we can see, or hopefully see that it does, is, first of all, it imports the BlueDot library. It creates a BlueDot object. And then it waits for the BlueDot button to be pressed. And we'll see how that works in a minute. And then this is like the super simplest program. Just prints out a little message to say, you press the BlueDot. So let's have a go. So if we run this program, we run our program, we should say, oh, a server started, just telling us we're waiting for a connection. And if we look on our Android app, these are all the Bluetooth devices that happen to be paired with my phone. So before this session, I paired the Raspberry Pi that's in my robot to my Android phone, and it's called Robbie because he's a robot. So let's connect to Robbie. So it's waiting for his connection. We click on Robbie, tells us we're connecting to Robbie, and it connects, and we can see. And it's at this point in our program's here. It's waiting for us to press the button. So let's do that. We press it, and we get a message up. Hurrah! We have successfully tested it, and that was kind of my initial sort of aim for BlueDot, was that it would be, as simple as creating a physical button, or hopefully as simple as creating a physical button. All right, so let's do something a little bit more exciting now. This is, robots are all about kind of physical computing. And if we look at our robot, we can see that there are two LEDs on the back of my robot. They were originally meant to be headlights until I realized I'd put them on, I'd drilled the holes in the back, at which point they became brake lights. Right, that's cool, right? So what we're going to do is, this is my little starter program. So I've created an LED, and I've created BlueDot, and I've imported BlueDot. And you're going to have to trust me, one of my LEDs, I can't remember which, is connected to pin 16. So let's do something a little bit more physical with this. So what I want to do is, when I press the BlueDot, I want the LED to turn on. And when I release it, as in I stop pressing it, I want it to turn off. But let's do the first half of that. So the first thing I'm going to do is I'm going to create a function. Now this function is going to be what's going to happen when I press the button. And very simply, what I'm going to say is, my LED, I want you to turn on. Now, once I've created my function, so this is the thing that I want to run when I press the dot, I need to tell the dot to do it. So I'm going to say, when pressed, run the pressed function. And that is it. That is our program. It's hopefully when I press the BlueDot button, it's going to turn on the LED. And with everything, we should always give it a little bit of a test. So I run it. Our program is running. I need to connect to Robbie the robot again. We connect. Hopefully. Oh, there we go. Right. And again, it's waiting for me to press the button. So I press the button, and if all goes well, which the LED comes on. Brilliant. Right. Let's finish this program off, because at the moment it only does half the things we want it to do. It only turns it on. It's not going to turn it off. So let's just stop that program. And there's no trick questions here. We're going to create a new function called released, which is what's going to happen when I release the button. And I'm going to say off. And then we're going to say bd.when underscore released. And we're going to say run the released function. Again, it's a good idea to test our program. So I'm pretty confident it's going to work, but let's have a go. Let's connect to Robbie again. And we press the button. And the LED comes on. You can't see me, but I'm holding it on. Perhaps if I come in here, I'm holding it on. And then if I let go, it goes off. And I can keep doing that. Flash, 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 flash. Press, 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 long, press. Let go. So that is the sort of essence, I suppose, of what BlueDot does. Right? It is a wireless button that you can hook up to do things. But there's a couple of really interesting things about BlueDot. I'm just going to nip back to my slides. I'm also going to take a drink of water. So I think the first thing we can note about BlueDot is it's a pretty big button, right? And one of the really interesting things about this is, because it's a pretty big button, actually you can press it in lots of different places. So for example, you could press it in the middle, or you could press it, towards the top edge, or the left, or the right, or the bottom. So actually, we can start to segment this up. So actually, have I got one button here, or have I actually got 5? Yeah, I've got a button at the top, a button at the left, a button in the middle, and a button in the right. It's a big button. We can do things with it. So I think we should, again, let's try and take this forward a little bit. And what we're going to do is we're going to say, okay, well, if I press at the top, I want the LED to turn on. But actually, if I press it at the bottom, I want it to blink. So let's do that. Right, so I need to go back to, oh, you can see my code. I'm giving you like a preview. All right, so let's go back to our program. So this is where we start, right? So it's the program we just had. When it's pressed, it's going to turn the LED on, and when it's released, it's going to turn it off. But what we want to do is we want to change that. Now, one of the things that BlueDot will do is when you do something, yeah, it will call that. So in this case, when it's pressed, it's going to call the press function. But it's also going to pass to this function a parameter called a position parameter, which is basically where I've pressed the button. So I can say things like if pos.top, in which case let's make it turn on. We'll do an elif pos.bottom. So if you press it on the bottom, we're going to say my LED, and instead of making it turn on, we're going to make it blink. So let's give that a go. So we're going to run our program again. There's going to be a sort of pattern here. Write a bit of code, do a bit of talk, run it. So we connect to Robbie again. Now, oh, there we go. Right, lovely. Now, if I press Robbie, the big button on the top, our LED turns on. And again, when I release it, it goes off. But now if I press it at the bottom, what we should see is that it starts to blink. So suddenly what I've got is not just one button. I've got sort of like 5 buttons in one, pretty simply. And having sort of 5 buttons in one leads us to the point where actually this is starting to get interesting. We should probably make our robot move. We have got at least five buttons in our one button. So let's make our robot go forwards, go backwards, and then let's see if we can make it go left and right. What I'm going to have to do is just put the battery in to power the motors. There we go. All right, so this is where we are going to start with our program. All right, so it looks pretty similar to what we've just seen, the program where we were turning an LED on or making it blink. Big difference is I'm using GPIO 0 and I'm going to use the robot class of GPIO 0 to control my robot. You're going to have to trust me that my robot's got 2 motors in it. Left is connected to pins 8 and 7, and right is connected to pins 9 and 10. All right, so what we're going to say is we're going to say, well, if I press at the top, pretty simple, robot.forward. Okay. And then if I press it at the bottom, we're going to say robot.backward. And there's another thing I should do. We know that if robots start moving, they don't stop moving unless we tell them to. So actually, I think the other thing I should do in our program is when the button's released, let's make the robot stop. Otherwise, it's going to fly off my very small table. All right. Let's give it a run. So we run our program. It's waiting for a connection. So let's connect to Robbie again. Now we find out if my robot works, because they do have a habit of being temperamental. Really interesting to see the videos this morning. Right, so let's press at the bottom. Hopefully, go backwards. Yeah, it goes backwards, and we press at the top, it goes forwards. Excellent. So now suddenly we've got a sort of simple robot controller that we can use to drive our robot forwards and backwards. Let's finish this thing off. All right, and what we'll make it go left and right. And again, there's sort of there's no trick questions here. Is if we press the button on the left, we want the robot to go left. Otherwise, if we press it on the right, we want the robot to go right. Lovely. All right, great. Let's give that a run. Right, so we're running. We're going to connect to Robbie. And yeah, forwards, backwards, and now we've got left and we've got right. So we found ourselves with a really simplistic robot controller. This sort of feels like quite a nice time. Is this a nice time to see if we've got any questions? Because I feel like I've been talking for a while and doing quite a lot of things. So I'm just going to nip back to the screen. Okay. No, I think we're all good. Well, if there's anything you want to ask me, Otherwise, I'll carry on. Oh, good. Can the dot show the 5 areas? No. Just top, bottom, left, right, middle. Yeah. Martin, have you seen this problem that it didn't work? I think I will sort out debug for. If I run on Raspbian Lite over SSH, sudo user mod g Bluetooth dash. I think that's what. Oh, blimey, we've got like error. No, I haven't. I mean, what that suggests to me is like using Raspbian Lite with absolutely none of the software installed. You're going to find yourself having a tough day.
We have some questions before that.
Oh,
if you want me to go through what we've got so far.
Yeah, let's have a bit of a break because I feel like I've been talking for a while.
Sure. Rich Maynard says, you are so brave for doing this live, and I completely agree. Live coding is always so well done.
Thank you. Yeah.
Alistair Ware said that he's got an ESP32 with a Bluetooth shutter release.
He has, and Alistair helped me do some testing with BlueDot 2 as well, which was really helpful.
So is he using BlueDot on it to control his ESP32?
Yeah, so I'm pretty sure Alistair is using the BlueDot Android app, but has created an ESP32 equivalent of the Python library.
Cool. So he's so you can run this not just on a Raspberry Pi, but on anything that can run Python potentially.
So one of the sort of prerequisites to getting the BlueDot Python library to work is access to dbus. So that's how it communicates with Bluetooth. Really, you're sort of limited to Linux, really.
Sure.
So there's another kind of question: is BlueDot Android only? It is, and one of the challenges and one of the reasons it's BlueDot only is because sort of in 2017 when I wrote this, I wanted it to be not only simple to use but simple to install. And actually, to make it simple to install, really, I had to use RFCOM in Python, and RFCOM is not supported by iOS, is the long and short of it. However, times have moved on, and actually one of the things I want to look at probably for BlueDot 3 is using Bluetooth low energy, rather than Bluetooth classic, which is what it uses today. Yeah.
And one question that came up was, I guess maybe you've already answered this with the talk of dbus. But Neil Stevenson said, any plans for Pico app?
Pico app?
Yeah.
I mean, probably not, because Pico doesn't support Bluetooth. So I'm just not sure how we would get that comms working.
Well, but like maybe if we connect up and whatever they're called, HC06 or something. You know,
maybe. Yeah. I mean, the sort of software stack required to run the BlueDot in Python is pretty heavy. So the kind of MicroPython, I would effectively be rewriting the BlueDot Python library, which I'm not against. Yeah.
Okay.
Yeah. In terms of Daniel's question, I don't, and to be honest, I don't think I've tested BlueDot on Raspbian Lite for a long time. I mean, my gut feel says it's probably a serious lack of software required to support it. What I would love is to have a BlueDot fake / emulator controller. Oh, right. Okay, there is one. There's a mock BlueDot app as well. Because one of the problems with testing BlueDot is it's quite a long time. Like, make a change, you connect on the Android app, you then do the thing. There's a mock one where you can just like launch it in a window, which is like super easy, and it does the. Yeah, have a look at if you look at the documentation. Somebody asked, "Is there a Raspberry Pi tutorial?" There is. Find it, and I'll share it at some point. Cool. Shall I carry on?
Yeah, I'm going to get off stage now and then get back to it.
Lovely. Right, I need to get on my Windows back. Right, because we need that one, and we need that one, and we need this one. All right. So let's go back to slides +1. So we sort of showed how we can use like positions of the button, like the top and the bottom, the left and the right. You can also use actually very precise positions, including things like angle and distance, which is, going back to our sort of robot example, like really, really helpful if you want to do things like controlling the speed of a robot. So the further I push it up the dot, the faster it goes, as an example. The button is also more than just a simple push button, right? You can also drag the button, so you can sort of drag across it, and you can get, so where we're using like when pressed and when released, you can also do things like when moved. So you can actually tell when somebody's finger moves across the button. You can also do things like rotate it. So I don't know if anybody remembers the original iPods with the big circle, the click wheel. You can use it just like that. So you can rotate left and rotate right. You go tick, 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 tick. Because it's quite a big button as well, you can swipe it. Yeah, so you can go left, you swipe it left, swipe it right, swipe it up, swipe it down, blah, 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 blah. Cool. So yeah, more than just one button. It's actually a pretty comprehensive button. Also, I suppose the thing that I would just point out is this, that also the button doesn't have to be blue, right? It can be any color you want, and actually you can change it in real time. So one of the things that I quite often do is if I'm using BlueDot to control something, I change the color of the button to indicate what state it's in. So if I press it to make a light come on, I'll change the color of the dot to be red. Yeah, and then when I press it again, turn it off, I'll perhaps make it back to blue or something, right? It also doesn't have to be a circle; it can be a square, or actually it could be entirely invisible. Yeah, you don't have to have a button at all; you can just have a blank thing, but it still reacts. Yeah, lovely. Right, I'm just going to take a drink of water. So, that's the sort of background, the history, and I suppose the introduction to BlueDot. Now, in BlueDot 2, which came out a few months ago, you can have more than one button. And for a long time, I was sort of quite reticent to make this change because one of the big benefits to BlueDot is that it's super simple to use, and it should always be that. And actually, I really struggled to come up with a way that I could introduce more and more buttons, or make it have the ability to create a more sophisticated controller, but maintain that really simple user interface. And the simplicity is the biggest priority for me. Yeah, not features. But yeah, came out a couple of months ago, and you can have more than one button now. Now, in actual fact, you can have as many buttons as you want, provided they're arranged in a grid. Yeah. So here is 8 buttons in a 4x2 grid. Now, using this approach, you can start to build up any sort of controller you want. So, for example, the joypad controller that we saw right at the start of the presentation is actually a set of buttons in a 7x3 grid. So 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, and a 7x3 grid. Now, most of the buttons are actually invisible. So like any of the ones you can't see, they're just invisible buttons. They're actually still there. Now, the direction buttons are squares and not circles, and 2 of the other buttons have been given a different color. Yeah. But what we start to see is very quite simply, quite sophisticated the fact that you can create quite sophisticated controllers. All right, so let's go back to that blue button example. Now, you will notice, well, you may have noticed that there are 2 LEDs on the back of my robot. Wouldn't it be great if we could have one button to control each? So that's the kind of next activity we're going to do, is we are going to see if we can wire up 2 buttons to BlueDot. All right, let's just switch back to here so we can see. Right, so this is the program we're going to start with. Oh, I've managed to put a dollar symbol there. So again, I'm importing the modules I need. I'm creating 2 LEDs, one on pin 16, one on pin 26. I'm pretty sure they're the right way around, but they might not be. And I'm creating BlueDot. So our job is we are going to try and hook up one button to the right LED and one button to the left LED. Now, the first thing I need to do is I need to tell BlueDot how many buttons I'm going to have. Now, going back to that, what we first saw is that we need to, all the buttons are in a grid. Now, actually, 2 buttons, if you imagine it, are just a grid that is 2 columns by 1 row, right? And that's how we do it. So when we create our BlueDot, oh, I've lost my presentation notes, which is a bad thing. Right, hang on, guys. I'm just going to restart my presentation because otherwise I can't see what I'm meant to be doing. Give me 1 second. There we go. Oh, no, I got all the slides now as well. And remember where we were up to. We were doing like LEDs and 2 buttons, weren't we? Right, brilliant. Okay, right, cool. So we're back here. So we need to tell BlueDot how many buttons to create. And again, going back to that those two buttons are a grid of that is 2 columns wide, yeah, by 1 row, right? Now, interestingly, 1 is the default, so actually I don't have to tell it how many rows I want. So that will give me 2 buttons. Let's run it and find out, because it's kind of useful to see these things. So I run my program again. I connect to Robbie. And what I should see now is a controller with 2 buttons on it. Yeah, brilliant. That's good. So we sort of proved that works. That works. All right. So let's wire up the first button first, as in the first button, the one on the left. Right. So the way that BlueDot arranges its buttons is in that grid with sort of X, so columns, and Y. Yeah, with 0, 0, as in column 0, row 0 being on the top left. So my top left button will be 0, 0. So now I can say, okay, well, when the button on the top left is pressed, the button that's at position 0, 0, I want you to turn on the right LED. So we can say right LED, and we can say on. And what that will do is it's when that button is pressed, it is going to run that function, which will turn on that right LED. What we should also do is turn it off when we release it, otherwise it's going to stay on forever. When released equals right LED off. Lovely. Give it a run, because we don't know if things work until we run them. Yeah, I'm hoping it's. Let's just move that. Cool. So we connect to Robbie. We've got our 2 buttons. Hopefully. Well, yeah, okay, great. Right. So hopefully, if I press that button, one of the LED comes on and goes off. However, if I press the other one, it doesn't do anything yet. It doesn't do anything because we haven't programmed it to do anything. So let's hook that fella up. Well, so going back to this index, so that's the column and that is the row. So the next one is in the column along, so it's going to be 1, 0. And rather than the right one, let's make it turn the left LED on. And the left one again. Let's run it again. And if it works unless we run it, do we? And again, so we got left and we got right. And they're doing what they're meant to be doing. So, actually, you know what? I think the other thing we should do is let's make the buttons red, because at the moment they're blue, which is just sort of, it's a bit jarring, isn't it? Now, interestingly, one of the things I can do with BlueDot is, even though I've got multiple buttons, I can still use the BlueDot class itself. And when I say things like .color, it will turn all of the buttons red. I could have done, BD 00 .color equals red as well, and that would have just changed the one button. It would have left the other button in its default color, which is blue. But let's change them both. So again, let's just run it, make sure things work. There we go. Now we've got 2 red buttons that match our LEDs. Great. We're doing good. All right. So where are we? Let's go back to our slides for a moment. All right. So we are going to create that joypad. That was what we set out to do at the start of this session, was to create this joypad that used BlueDot. Now, again, let's just have a quick look at it again. So let's remind ourselves, this is a grid 7 by 3. Some of the buttons are squares, some of them are different colors. Let's do that. Let's go through that process of actually creating this controller, and then hopefully we'll have a little bit of time where we can hook it up to our robot as well. Right then. So let's do this. Let's go back to this one. So you guys need to see my code. All right. So the first thing we need to do is we need to tell BlueDot how big we want it to be. I mean, there's something I'd also say as well is that what I'm doing now is sort of like setting up a controller and then running the program. It's worth noting that actually you can change the controller in real time. So if somebody presses a button on the left, that means make it a different sort of controller. You can do that. Right. So let's create a 7 by 7. Now, I think the first thing to know. We're not doing what we said to do, which was run it. Let's have a look at it. Oh, I've done it wrong. Cold equals 7. What have I done there? Well, first of all, I've done colds twice. We should probably do that, shouldn't we? Rows. Let's run that again. And now, perhaps not surprisingly, what we're going to see is, loads of buttons in that sort of grid structure. Right, now, the thing about that joypad controller is actually most of them are invisible. Yeah. So what we could do is, go through and set all of the buttons that are invisible individually. But actually, what I think we should do is if we set everything to be invisible, right? So we set its visibility to false. That's going to make all the buttons invisible. And then what I think we should do is make the 4 buttons just the buttons that we need. So button 1,0 is the up button on the D-pad. Because if we do this, we have to write this code. Yeah, because there are less buttons that are visible than there are ones that aren't. And again, let's just run it and give it a go. Hopefully what we should see, yeah, just one button is visible, which is that button there. That button is going to be the top of the D-pad. Let's add the next one in. The next one's in. In fact, do you know what? To speed things up a bit, because I'm sure you guys are getting slightly tired of watching me type. Let's do some cut and paste. So we got up, down, left, right. Excellent. So now we've got our 4 D-pad buttons. Let's give it a run. Running. Okay, we're getting there. So it's starting to look like a controller. Yep. We're missing our 2 buttons on the right, so let's create those guys. And again, I can't imagine you guys like that. So you have to trust me, but the first button on the right is at position 4,1, and the next one is at position 6,1. Again, let's run that. Let's have a look. See what happens. Right, looking a lot more like a joypad. There's still a couple of things that are wrong. First of all, our D-pad is not square. Right, let's make it square. And I'm going to use the same trick. I'm actually going to say, right, I'm going to make everything square and then just make the things that I don't want to be square not square. So let's make everything square, and then these 2 buttons I don't want to be square. So what we'll do is we'll nick that bit of code, and we will make these false. Yeah. Oh, I can't. Typing skills are starting to fail me. Right, again, let's give it a run. What are we looking like now? Much better. Let's finish it off. Let's set the colors of the 2 buttons, because one of them was going to be red and the other one was going to be green. Yeah, let's just do that. And I'm just going to cut and paste that code because, yep. So first button we make red, the second button we make green. Give it another run, and where do we get to? Okay, so we've got a controller. Brilliant. That's sort of good, yeah? We've got a controller. And we can hook up all the individual buttons for that controller to do different things, whether that's making the robot move forwards or move backwards and turn on LEDs. Doesn't matter. We can do kind of like whatever we want with that. So is now a good time to stop for some questions? Yeah, let's do that. And if we have a little bit of time at the end, we can hook the robot up and make it move based with our new joypad. But I want to give guys a chance to answer some questions. Let me go back.
Okay, we actually have someone who's queued up to share their video.
Oh, great!
I don't know if that was deliberate or not, but I'm gonna put him on anyway. So let's bring Iwan on in case that's an actual request to say something. Hello. Oh, and he's gone. No, okay, fine.
Oh, okay.
No, never mind. Right, in that case, we had one question, which was, where are the docs? And Sumit said they're on BlueDot.readthedocs.io. Right?
They are, yes. Yeah, absolutely right. Yeah, so you'll find all the documentation there. What you'll find is a getting started guide. What you'll also find, which I think is more important, is a load of recipes. So sort of examples of, I want to make an LED turn on, I want to create a robot, and it will give you a recipe code for that. And for those who are interested, there is also a complete API reference as well. Yeah.
Cool.
It's a comprehensive bit of documentation, I think, is what I'm saying.
Ford has just asked, is there any ability to show text with the buttons or a list below them?
No. And that is something that has been asked before, and I have shied away from it. And the reason I've shied away from it is that, going back to my first point, simplicity to me is more important than functionality, right? So actually, that's not to say I'll never do it, right? I did, but the things that I prioritize is making BlueDot simpler to use, yeah, and more useful rather than adding features, yeah.
And I just had a couple of questions. One is, you've been referring to these buttons with their grid position. Is there any way that I could name a button and refer to it by name, or just by their grids forever?
No, so I suppose what you could do.
You just find into a variable and then use that variable.
Yeah. So you could do up equals BD.
Yeah, sure.
1. Somebody was getting upset about my lacking of a space.
Yeah. Well, they're quite right. It's in Pep 8. We've had.
I mean, yeah, maybe, but if you're live coding stuff, spaces are less important.
Yeah, all right. I'll let you off.
Yeah.
Yeah, I get it.
So you could do that.
And the other thing is, I saw those LEDs flashing pretty quickly. What's the latency like here? Could I drive a fast remote control car with this? Yeah. I think genuinely what I've found is that the things that make this slow, right, is not BlueDot. Yeah. It's somebody presses up and they're going to do a load of processing before they actually do the action that they want. Yeah. There is a way to thread BlueDot as well. So you can thread events. So you can say when this thing is pressed, you can actually get BlueDot to thread that and to launch that in its own thread. It's not the default though, because things can start getting weird really quickly. Yeah. But yes, generally pretty quick. And actually, what underpins BlueDot, and I suppose the first thing I wrote for BlueDot was a really sort of super simple Bluetooth comms library. And actually, I quite often use that on its own, and you can send quite a lot of data very quickly. But it suffers with all streaming protocols. Sending lots of data in one message is really quick. If you want to send lots of things, little bits backwards and forwards, it gets much slower. Cool. Do you have any more to share with us?
Yeah. Well, if we've got time and people want to hang out,
if we go another 5 minutes, we can get away with that, and then maybe take one quick question at the end, and then that gives me time to have a little break and get a cup of coffee before the next session.
All right. I reckon in 5 minutes we can connect up that joypad that we just created to the robot, make it move.
Let's do it.
Right, we're probably going to end up doing quite a bit of cut and pasting, but let's have a go anyway. Right, so first things first, let's make this thing. What are we going to do? All right, let's make it go forwards. Right, to make it go forwards, right, I'm going to need a couple of functions. I'll stick them in. Right, one that makes one that we're going to use when we go up, and one that we use when we stop. Right, and where's our up button? Here's our up button. Right, what we're going to do is we're going to say, right, when the up button is pressed, make it go forwards. When the button is released, make it stop. Yeah. Again, it's hopefully this. What we're saying is that even though it's a more complicated controller, it's still pretty simple. All right. So let's run it and give it a go. Oh no, robot is not defined. Oh look what I've not done. I've not actually created the robot. Oh, silly, wasn't it? Right. Let's create our robot. I'll stick it there. Run it again. Hopefully it runs now. Nice. Oh, this is a moment of anticipation. Oh, there we go. Right. So let's push up. And nothing happens. Why does nothing happen? Unsupported operand. Oh, I know what we've done. Look.
Got old code in me, old code in me thing. Right, let's do it. Let's call our functions instead. There we go. Hey, now it goes forwards. Okay, so we can now make it go forwards. Right. Let's finish this job. Let's do down, left, and right. And again, we need a few more functions, which are basically the functions we're going to call. You know, I said I'm not that worried about formatting, but I can't quite leave that like that. And then what we need to do is, if we take our 3 buttons, the other 3 buttons on our D-pad, we need to hook them up to those functions. So that is the down button, that is the left button, and that is the right button. So let's hook those fellas up, give it a run. And now, hopefully, we have a fully functioning joypaddy robot thing. Right, up. No, oh no. Who's broken this? Probably me. What have I done that means this is broken? Up, down, left, right. Do you know when you just want to give it just another go, even though you haven't changed anything? You know? No, right. I've broken it. I'm starting to think maybe things like batteries and things like that, but that's a bit weird, isn't it? Because it says we're connected. It should be doing something. Right. I'm going to give this up as a bad idea, but you know, I'm sure what we can start to see is that is how we apply the same process. You know, each one of our buttons, you know, so you can create a controller with many buttons, acts in the same way as an individual button. Yeah. Interestingly, you know, even if it's a tiny button, say you've got a matrix of millions of buttons, right? They all work in the same way. So interesting, if you had small enough fingers, you could still do the swipes and the double presses and things like that, right? Cool. So I think I'm about up with time, so we can give Rob a wee break.
Thank you very much. Yeah,
because I'm guessing that's what you need, right?
You know what? I wasn't going to say it, but yeah, that would be nice. And I think a few other people might want a chance to get a sandwich before we go into the next session, because it is getting on for lunchtime. Just a couple of quick questions for you before we finally start. Kevin Hainsworth says, can BlueDot be used as a Bluetooth camera shutter release? Now, I guess on a regular Bluetooth camera rather than a Raspberry Pi.
Oh, I see. Right. I mean, you would have to have something in between the camera and the Android app, right? So, for example, Alistair, one of the things he does with an ESP 32, I think, is he does exactly that. He uses an ESP 32 to trigger the camera. Yeah, but provided you had something in between, then yeah, absolutely. But you would have to have something in between.
And just bringing it back to PyWars for the last question, would BlueDot cope if we were all trying to use our BlueDot to control our PyWars robots in a room of 100 people all running robots with BlueDot?
Yeah, probably. I mean, so one of the reasons that I chose Bluetooth when I was sort of first looking at these controllers, because I looked at other things as well, is that that's exactly what it's made for. It's made for doing short distance control, and it's made with hundreds of small connections. I mean, one of the things we haven't explored is that you can have like one Python program with multiple BlueDots connecting to it as well, up to 30. There are 30 channels that you can use. But yeah, absolutely, and you know, I'd be relatively confident with that. There's an interesting story, actually. When I was testing BlueDot, one of the things I wanted to find out was how far away you could go, and I still haven't worked it out. Well, yeah, because one of the things I wanted to test was when I went out of range, did everything cope gracefully, did disconnect gracefully? I ended up having to use a Pi Zero, wrapping it in foil, and walking down the road, right?
So we should be all right, is the answer. So we can all use BlueDot.
Oh yeah, and I suppose it's the same technology. I know lots of people use like PlayStation controllers.
Yeah, that's what I've used personally. Yeah,
which are effectively Bluetooth controllers. It's the same technology.
All right, I think that has to be it. Thank you so much for that. That's been a lot of fun, and I hope you can stick around and join us for some of the rest of the conference.
Yeah. Oh, look at that! Oh, see now, Barry says I have to put this out because Barry knows everything. Bluetooth frequency hopping makes it robust in busy environments, and if there's anybody to believe, it's Barry.
All right, well, that's the last word on it, I'm afraid.
Right,
I will see you back here in 2 or 3 minutes for the Makers panel, I hope.
Thanks a lot. Bye.
Cheers.